All right, so let's talk about raster data models. Raster data is used for aerial and satellite imagery, land use and land cover, statistical surfaces of things like elevation or precipitation or temperature. It can come from scanned maps. Say if you scan in a paper map to make it digital, or really any image that is, say, a JPEG or a GIF or a TIFF. And it can also come in the form of conversion from vector data, which you might do to make your GIS analysis a bit easier. Ultimately, rasters are really tessellations, which you might have heard of before. Tessellations are a regular or irregular covering of a plane with no gaps or overlaps. Think of this like tiles you might find around a pool or in a bathroom. The tiles of raster data are often referred to as pixels, cells, values, or sometimes squares. Nearly all raster data in GIS uses square tessellations. Think of this as the most boring and basic tile. Just like in basic bathroom tiles where each tile has just one color and together they make a cool pattern, in raster data, there's just one value for the whole area of a cell. In 2D, the way you see that looks like this, or this, or this. If this data were elevation like here or here, each cell would have a value. But then when we look at it in 3D, we might visualize it like this or like this, where we visualize each cell value as a height. This also works for other types of statistical surfaces like rainfall, where the height of each cell is the value of the rainfall for that cell. For categorical data, like this land use land cover data set on the far right, we can see that each cell represents just one type of land use. How is data stored in a raster data model? Raster models work best for representing continuous data, but they can also be used for discrete data. Cells are or have to be homogeneous. They have crisp boundaries, and you can only have one category or value per cell. This leads to some classical limitations of raster data. First, we can only represent one value or category per cell. For instance, here in B, if this was showing different cities, we'd have to decide which is the most central or most relevant city to represent with that one cell. In example C, we can only represent one line, so we run into the problem of having to decide how that gets represented. Here are some other examples. And how the program might make decisions. For instance, in a winner takes all example, the largest area in the cell is then represented in the raster data. Here, A, C, and D are categorized as land, and B is categorized as water. The majority of either land or water determines what the cell becomes. But we can also make a decision on what is most important for our analysis. In this case, it might be that we're trying to find water in our map. And so we rate water as important, and each cell which contains any water is then categorized as water. So even here in D, where water is only, say, less than a quarter of that cell, this becomes a water cell because we're interested in finding where water is in our map. In short, what each cell becomes requires a decision, which may change how the raster looks. This map would look very different if every cell that contained water was categorized as water versus a winner-takes-all type of situation where only a few cells would be categorized as water. Some of these cells. How these types of decisions are made is up to humans, but may be completed with machine learning, which you would learn about if you take Geography 281. Finally, how data is represented depends on the type of data that you have. You can represent binary data, ones and zeros, say 1 where there's water and 0 where there's not water, by showing ones and zeros as white and black. We can also have values that go from 0 to 255 and show that in grayscale because we have 256 levels of grayscale here. We can also display things as a color map image. A color map is when a set of values are associated with specific RGB values. So here, when we have a value of 2, that gets represented by these sets of RGB values, which is purple. And if we have a 1, that gets shown by these sets of RGB values, which is yellow. Each pixel value is associated with a color defined by those values. And since each value has a distinct color associated with it, it will always display the same way each time. And finally, here are some of the main raster formats. TIFF is the most common that you'll probably encounter. We also have GeoTIFFs, Mr. SIDS, JPEG 2000s, Esri grids, and Erdas Imagine images, but there are many more.